You're walking down the street. You see a strange-looking antique shop called Ageless Trinkets of Mr. Bright. You're curious, so you enter there. You take a look at all the weird stuff. Suddenly, an old folded parchment paper catches your attention. It's a world map, but something's off with it. Instead of showing the countries as you know them, it shows the locations of 4 mythical lost worlds and civilizations. Mr. Bright, the shop owner, comes next to you after realizing your shock. This map won't let you find these places or anything, but I can explain to you the legends behind them if you want, he says. Let me begin with Atlantis. You might know it as Aquaman's underwater kingdom, but Atlantis, the fictional island, was actually first introduced in 2 of Plato's works. According to him, Atlantis was a highly advanced civilization that existed about 9,000 years before his own time, and its story had been passed down by poets, authors, and others. He wrote about Atlantis and its citizens to give a moral lesson and to teach about the dangers of arrogance, as well as the eventual downfall of those who are after too much power. In his dialogues, Plato stated that Atlantis was a great and powerful empire that was respected in all parts of the world. It was founded by beings who were half deities and half human, and became a great naval power after a while. Being an island filled with gold, silver, and other precious metals certainly helped their case. But besides that, it was also known for its breathtaking architecture and state-of-the-art technology, as well as its countless rare and exotic wild animals. Atlanteans were proud of their great achievements and the perfection of their civilization, but their excessive pride was going to bring their downfall. They believed they were so superior that they could gain control over any nation. This led them to launch a series of invasions. They conquered many of the Mediterranean lands, but when it was time to enter Athens, Athenians pushed back with an extraordinary force, so the Atlanteans were finally defeated. Plato stated that deities then got angry at Atlanteans because of how wicked, greedy, and immoral they became. So they punished them by sending earthquakes, which caused Atlantis to sink beneath the sea. Although the earliest written records of Atlantis were Plato's works, some people still believed his story to be based on truth and tried to identify the island of Atlantis with actual countries. Some people suggested it may have been located in the Mediterranean Sea, near the coast of Spain or Italy. Others thought it may have been located in the Caribbean, off the coast of Central or South America, but there was no solid evidence to support any of these claims. One theory, in particular, seemed more plausible than the others, though. Located in the Aegean Sea, the island of Santorini was the home of a highly advanced Minoan society. However, due to a huge volcanic eruption, it was destroyed about 3,600 years ago, causing the Minoan civilization to suddenly disappear. These similarities between the fictional Atlanteans and the historical Minoans made Santorini a good candidate for the speculations. Yet again, there were still major flaws with it, such as how the time when Plato said Atlantis was destroyed doesn't coincide with the time of Santorini's eruption. So Atlantis still continues to be regarded as nothing more than a popular legend in the scientific world. Now, let's move toward the northeast direction on the map, Mr. Bright says. According to Celtic Breton mythology, there once was a magnificent city called Ys, also known as Caris, that towered over Douarnenez Bay in France's Brittany region. It was the most wealthy city in the entire Atlantic. It was especially famous for its beautiful gardens and buildings, and its citizens were all living comfortably and happily there. Dahut, who was King Bradlon's daughter in Breton legends and literature, had a deep love for the sea. She begged her father to build a city at the edge of the sea, and that is how the city of Ys was established. Little did she know that she would be the one responsible for the destruction of her father's beloved gift. You see, since the city was surrounded by the sea, it needed to be protected by a dike equipped with floodgates, and these gates could only be opened at low tide. and the only one who had the keys to these gates was the king himself. One day, a handsome red knight arrived at the city, but couldn't pass the gates. Dahut was so taken by him that she wanted to let him in. She knew that her father was the keeper of the only key to the city, so she sneaked into his room and stole it from him. Then she gave it to the Red Knight so that he could enter the city and they could be together. However, the Red Knight turned out to be the Prince of Darkness, and he intentionally left the gate open to the raging sea. The waves soon swallowed all of Ys. King Gradlon was able to escape on his magical horse, but Dahut couldn't. She turned into an evil mermaid who lured sailors into the sea. Today, if you go to Quimper, a city in Brittany, northwest France, you can find the statue of King Gradlon riding on his horse. Although the city of Ys is a legend, Brittany coast locals believe that on the days when the waters are calm, you can still hear the tolls of the city bells deep under the sea, if you listen carefully. Mr. Bright then points at the Indian Ocean on the map and says, "Now, have you heard about Lemuria?" Back in the mid-1800s, a few scientists suggested that there was once a continent that existed in the Indian Ocean, somewhere close to the south of modern-day Sri Lanka. The first one to popularize this theory was the British lawyer and zoologist Philip Lutley Sclater. In his paper, The Mammals of Madagascar, he stated that he found lemur fossils in India, and not in Africa. However, this discovery was extremely shocking to him because of the fact that lemurs' original homeland, Madagascar, is much closer to Africa. He proposed that this was possible only if some larger continent connected the two once. He stated that this continent must have eventually sunk to the ocean floor. He then named it Lemuria, and hence the theory was born. People who came after Sclater took his theory a step further and thought that Lemuria was also the home of an extinct race of humans called Lemurians, who had 4 arms and enormous bodies, and were also the ancestors of modern-day humans, as well as lemurs. Of course, as new scientific discoveries were made on plate tectonics, evolution, and the study of DNA, the theories regarding the fictional continent called Lemuria were debunked. The last fictional land on the map is Agartha, Mr. Bright says. Taking its roots from Eastern mysticism, one legend says there's a kingdom called Agartha that is located deep beneath the surface of the earth. It's where all 4 corners of the world are connected by paths and tunnels. It is said that there's a secret entrance into Agartha hidden in the Gobi Desert, and it's built by Agarthans themselves using advanced technology that can't be detected by us, the surface folks. According to some beliefs, Agartha exists to counterbalance the energies of those who live above the surface. While we live in a state of rush and heightened emotions, this world beneath us is the total opposite. Some even say that those who escaped Atlantis fled here to continue their lives inside the Earth's core. And yet, others think it's actually a land that's crawling with all kinds of monsters. But there's no need to be scared, since modern science proved Earth's core is not actually hollow and is a solid hot iron ball. So you can cancel your journey plans to the center of the Earth if you've made any. Thanks, Mr. Bright. In 1991, somewhere in the lush jungles of central Vietnam, a local logger found a mysterious hole among the foliage and bushes. He looked in there and felt a strong wind blowing into his face. Then he heard a strange sound from the cave depths and realized that it was the sound of a river. The logger didn't check the cave, but decided to go back there with a flashlight and a rope. When he returned, he couldn't find the cave anywhere. He spent a few years searching for it. Finally, in the 2000s, the logger managed to locate it again. In 2009, he brought scientists to this place. They found out the cave, called Sundong, is the largest in the world. There's so much space here that you'll hear a long echo if you shout. Sundong's main passage reaches 660 feet in height in some places, which is more than half as tall as the Empire State Building. The area of the cave is so huge that an entire New York City block with 40-story skyscrapers would fit in there. There's a deep underground labyrinth under the jungles of Vietnam, hiding 3 of the largest caves in the world, and Sindong is number 1 on this list. The vast space inside is filled with various plants, unique microclimates, and different landscapes. There's a real jungle growing underground. It became possible thanks to the collapsed ceiling in some places. It lets sunlight penetrate there from above. There are huge stalactites 250 feet high on the ceilings and walls, which is more than the length of a passenger Boeing. They've been here between hundreds of thousands and millions of years. Some limestone deposits are more than 450 million years old. It means they've existed since the time long before the dinosaurs. Besides the jungle, there are also many rivers in the cave. They were formed because of rainwater coming down from holes in the ceiling. These rivers are smooth and fast, like slides in a water park. But riding them isn't the best idea, since they can carry you into one of those long labyrinths that the cave is full of. And we still don't know where they're going. You may find yourself in another unknown part of the cave. This is what happened in 2018. 3 divers accidentally discovered new areas in Sindong. The cave turned out to be much bigger than everyone thought. They dove into one of the cave's lakes and reached a depth of 256 feet. At the bottom, they found a separate tunnel. Divers lowered a fishing line with a lead weight there and found out that this place reaches a depth of 394 feet, and the tunnel is more than half a mile long. We still don't know the exact size of the tunnel. Sindong also connects to another huge cave. There are lots of things you can see in Sindong besides underground labyrinths and rivers. You can find spacious rooms with lakes, and you can walk for hours along dark mountain corridors. This place is strikingly beautiful, but dangerous at the same time. And the coolest thing is that you can take a walk here. Since 2013, Doong Cave has been open to tourists. It's not just an easy walk to take some selfies though. The expedition to the cave lasts for several days. For the first day and a half, you'll explore the 3rd largest cave in the world. And only after that, you'll reach Sindong. The path will take you through rivers, dense jungles, mountains, and rocks. You can meet many exotic birds, monkeys, and other animals. And according to many people, the way to the cave is even more impressive than the cave itself. When you reach your destination, you'll spend the next few days exploring Sindong. Together with other tourists, professional guides, and porters, you'll be sleeping in tents in different places in the cave every day. You'll see some stunning landscapes and, get ready for this, 400-million-year-old majestic fossils. There are also dark rooms with lakes that are good for swimming. Such adventurous expeditions become more popular every year. People who visited the cave call it the most amazing place they've ever seen. Another amazing cave is located in Indonesia, on the island of Flores. It's quite small, but holds amazing things inside. In 2003, a group of scientists discovered ancient artifacts here, including fossils of primitive tools, such as sharpened stones. Scientists realized that hundreds of thousands of years ago, this place was home to our distant ancestors. Then they found a very unusual female skeleton. That woman was only 3.5 feet tall. This is the height of the waistline of an average adult person. That woman had no problems with her spine or with the development of her bones, though. This and other skeletons found in the cave belong to some unknown human ancestors. Scientists called this species Homo floresiensis, or simply, Hobbit. The woman's weight was about 35 to 79 pounds. Analysis of the skull and bones showed she was about 30 years old. Hobbits probably lived on Earth between 190,000 and 50,000 years ago. There's a chance they met the ancestors of modern humans. The next cave is in Turkey. Imagine that you live in an old house and decide to make some repairs. You throw all the old stuff out of the rooms. The last place to sort out is your basement. You've hardly ever visited it and have no idea what's hidden there. But it's pretty spacious, so you decide to turn it into a room. You tear down the wall and discover the entrance to the cave. This is a tunnel that leads underground. you walk through the cave and see a real underground city. This happened in Turkey in 1963. One of the locals discovered a secret passage to a lost city in his basement. About 20,000 people could live there. There was enough space for livestock and food supplies. It's not just a maze of tunnels. There's a chapel, a school, stables, kitchens, walls, and other signs of civilization. The city was built in the Byzantine era, in the years 780 through 1180. It's not the only one down there and is connected to many underground tunnels and towns that stretch for several miles. Let's finish our journey in the strangest and most frightening cave. We're going to the southeast of Romania, near the Black Sea. Here, on a desolate wide plain, you can find a hole. This is a tunnel leading deep underground. The air inside the cave has high levels of hydrogen sulfide and carbon dioxide. Under normal conditions, the air we breathe contains around 20% oxygen, but it's only 10% here. You won't be able to breathe freely without an oxygen tank. The water and air here are poisoned. Almost no animals are able to live in such conditions, at least the ones we know about. And this cave is filled with 48 species of living organisms, 33 of which are new unknown species. Creeping things that live here can scare you, especially if you're afraid of bugs. Strange white snails and white spiders are crawling along the walls. An unknown species of leeches and transparent shrimp are swimming in the water. White millipedes with huge mustaches are creeping on the ground. Here you can also meet an unknown kind of scorpion with a transparent white body that doesn't look like any other kind of scorpion. Nothing here looks like ordinary animals at all. All creatures in the cave are white or transparent. They don't have eyes, but they have long paws and antennae whiskers that help to navigate in space. Plants can't live here without sunlight and clean air. This means that oxygen isn't produced in this place. So how do these creatures manage to survive? The answer is in the water. The surface of the lake and puddles here is covered with strangely moving foam. This substance is a living organism. It consists of 1 billion bacteria called autotrophs. Ordinary plants absorb carbon dioxide and use photosynthesis to produce oxygen. This cave is filled with carbon dioxide. Autotrophs absorb it and secrete tiny food particles. Bacteria feed on these particles. Larger organisms then feed on those bacteria, and so on. In the end, there's enough food for everyone. This process is called chemosynthesis. It's like photosynthesis, but uses water instead of sunlight in its chemical reactions. In this cave, evolution has created a completely unique biological system, separate from the rest of the world.
At some point in its long and very interesting history, our dear planet Earth was sort of snoozing, just doing its planetary thing, spinning around the sun. And then, bam, life starts getting fancy. Plants and animals start strutting their stuff, showing off their complexity. Fast forward a bit, about 65 million years ago to be exact, and a cosmic disaster strikes, or at least that's what we presume. An asteroid probably smashed into Earth, wiping out the dinosaurs and other big animals. We can't pinpoint specifics about the asteroid, but we do know that it was extremely large and it crashed into our precious planet, creating a dusty mess that settled everywhere. You can still find remnants of that dust layer in sedimentary rocks today. If you dig beneath it, you'll uncover a whole bunch of fossils. These prehistoric creatures were living it up before the asteroid crashed the party. Think of it as the planet going on a cleaning spree, leaving a bunch of empty spaces waiting to be filled. And guess who took the opportunity? Mammals. These furry little critters were the ones to rise to fame. But why is it that this disaster became such a great opportunity for mammals? It's pretty simple, actually. With no big bullies around, they grew, multiplied, and had a population expanse. All kinds of mammals joined to fill in the blanks. Primates, rodents, basically, the whole furry gang. We're talking about placental mammals, marsupials, and even egg-laying mammals, adding some serious variety to the mix. We like to think of primates as our closest relatives here on Earth. What's their story? Well, around 63 million years ago, just a couple of million years after the dinosaurs' final dance, the primates decided it was time for a family reunion. They split into two groups, the dry-nosed primates, who became the cool monkeys and apes we know today, and the wet-nosed primates, who went off to become lemurs and aye-ayes, hey-hays. The fun didn't stop there. About 58 million years ago, the dry-nosed primates began their own little mission. One special guest called the tarsier, arrived on the scene, featuring big eyes that were perfect for late-night shenanigans. This tarsier took a different path from its primate relatives, embracing its unique niche and evolving separately. To this day, the tarsier is the only primate that feeds exclusively on meat. These little guys have a taste for insects, small birds, rodents, and even lizards. But that's not all that makes them unique. Their eyes are twice the size of their brains. Also, their heads can do a full 180-degree spin, just like an owl. Because of their features, the tarsiers are the true kings and queens of the night. With their superpower of ultrasonic tracking, they can spot their prey instantly. Plus, their legs and feet are like springs ready to launch them into action. They've got this special ankle bone called the tarsus, which gives them those epic leaping skills. Hence the name, if you were wondering. But let's leave these little critters to rest and get back to our story, shall we? About 55 million years ago, the Earth cranked up the heat, literally. This sudden hot pod was a bit too much for many deep ocean dwellers and plants to handle, and they bid their farewells. But hey, every goodbye is an opportunity for something new, right? The oceanic mammals known as cetaceans, saw their chance and took it. They splashed into those empty niches, becoming the rulers of the sea. In this category of creatures, you can find the blue whale and the dolphin. A special primate guest made an appearance around 47 million years ago. Scientists now affectionately call the fossil of such a creature Ida. This little wonder caused quite a stir, initially hailed as the missing link in human evolution. But here's the hilarious part. It turned out Ida was not one of us dry-nosed primates, but a cheeky wet-nosed one. Moving forward to 40 million years ago, this is when another big event happened in the primate world. The New World monkeys, our distant cousins, decided to take a different path and branch off from our lineage of Old World monkeys. They packed their bags and set off to conquer South America, where they're still living it up today. What's the difference between the two, you might ask? Well, one crucial thing that sets them apart is the fact that the Old World monkeys had nostrils that pointed downwards. Around 25 million years ago, another troop of apes entered the scene, and these guys had something special, the lack of a tail. These unique creatures would go on to become our closest relatives. We're talking apes and great apes, the cool gang who share a whole lot of genetic similarities with us. The first ape to break free from the monkey madness was the gibbon. About 18 million years ago is when this little acrobat swung into the picture. A few million years later, the great apes made their grand entrance too. Orangutans were the pioneers, venturing into the wilds of southern Asia. We're getting closer and closer to the present. It was 7 million years ago when the great apes took a major fork in the evolutionary road. One path led to our ancestors, the future Homo sapiens, and the other path led to chimpanzees and bonobos. These two primate branches remained united for a few million years before finally going their separate ways. 5.6 million years ago, a game-changing ape called Ardipithecus made its way into our evolutionary history. It had a special talent, bipedalism. That's right, this was one of the first apes to walk on 2 feet, probably making its primate buddies raise an eyebrow or two. The real showstoppers, however, arrived around 4 million years ago, the Australopithecus crew. These were the earliest members of the Hominina hominina subtribe, our tribe. What made them so special? Well, probably the fact that they brought some serious tools to the game. Stone tools, to be precise. It seems that at some point in their evolution, these clever primates started using stones to make their lives easier. Now here comes a crucial turning point in our story. About 2 million years ago, our ancestors faced a food shortage. Survival of the fittest was the name of the game, and two strategies emerged. Group 1 went for stronger jaws, allowing them to chomp on tough foods like nuts. Group 2 had a different idea. They opted for weaker jaws, but bigger brains. They wanted access to a wider range of food options. Obviously, the bigger-brained group took the prize. And here's where our gang comes into play. Around 2.5 million years ago, a type of primate also known as handyman made its mark on history. These clever beings had larger brains and knew how to put those neurons to good use. About 1.9 million years ago, a new star emerged, Homo erectus. These creatures not only walked upright, but also had brains that were almost twice the size of the handyman's. They took the world by surprise, becoming the first of our direct ancestors to venture out of the African continent. They even knew how to tame fire. Approximately 700,000 years ago, the world witnessed a culinary revolution. The earliest evidence of cooking appeared. And around 500,000 years ago, our ancestors decided it was time to become a bit more fashionable, donning the first evidence of clothing. Our very own species came to be just 300,000 years ago. Told you we were late to the party. But the world was never the same after the appearance of Homo sapiens, the anatomically modern humans. Alongside our other relatives, we emerged, ready to conquer the world with our innovative minds and complex societies. The exact path of our evolution remains a bit of a mystery. But what we do know for sure is that Neanderthals joined the party around at some point too. As Homo sapiens flourished, so did our capacity for language. Modern speech is believed to have emerged almost hand in hand with our species. We started expressing ourselves, sharing stories, and shaping the world with our words. So, there you have it. It took 13.8 billion years of cosmic history for humans to make their entrance. Think about it. 99.998% of the time since the Big Bang, we weren't even around. Our species, Homo sapiens, is the toddler of the Earth's family, existing for just the tiniest fraction of the universe's timeline. Yet, in this blink of an eye, we've managed to unravel the entire story that led to our existence. The story won't end with us. It's an ongoing saga, still being written with every passing moment.
The Earth has three main layers. Two parts of the core, the dense, hot inner core, and the molten outer core. Then comes the mantle. And then follows the thin crust, the surface that supports life as we know it. At least, that's what we thought, because now scientists found a new mysterious layer located deep within the solid inner core. Earth's inner core is approximately 2/3 the size of the Moon. And made of nickel and solid iron, it's burning hot. The temperature at the center of our planet is the same as at the surface of the Sun. The outer core can reach almost 10,000 degrees Fahrenheit. It's difficult to explore it because we can't go there, and it's like looking through a really dirty window of 3,200 miles of molten metal and rocks. But we can rely on laboratory experiments on heated pressurized rocks, signals from seismic waves, and computer models. When an earthquake hits, it sends out seismic shockwaves. Those waves travel through layers at a different speed, depending on the direction they go and the material they move through. In the new study, a team of scientists set a data set of 100,000 deep earthquakes. Some of them went over 60 miles below the surface. When an earthquake happens on one side of our planet, scientists track its waves all along to the other side. Waves change when they come to the other side, so scientists try to understand the materials these waves have passed through. They found a new layer in the core of our planet thanks to earthquakes. Normally, shock waves travel along the equator, but down below, they digress and go into different directions, about 60 degrees to the side. When waves pass through the inner core going from north to south, they will travel more quickly than waves going through the core parallel to the equator. It's important to understand the core because it creates our magnetic field, which, in turn, protects the planet from things like solar winds that are charged particles coming from the sun. In the 1960s, we discovered the Earth pulsates every 26 seconds. It's like clockwork, a giant heartbeat. The ground is slightly shaking, but we mostly don't feel it. Researchers can still track it. Some of them think the continental shelf comes as a huge wave break under the oceans. For example, the highest part of the North American continent falls off into a deep abyssal plain. One theory says waves hit this spot, producing regular pulses. It's like having all kinds of drums. You hit them with your hands and accidentally slam that one spot that produces the right harmonic bang to rattle our entire planet. If this theory is true, we're lucky there are no more spots like this that can shake the Earth. Other scientists believe the pulsation happens because there's a volcano near the critical spot, the island of Sao Tome in the Bight of Boni. You're walking, running, and jumping, but when you stop, it always feels like you're standing still. In reality, you're moving even when you're perfectly still because our planet is always on the move. Depending on where you're at, you could be spinning through the universe at more than 1,000 miles per hour. If you're on the equator, you'll move the fastest. Let's say you have a basketball spinning on your finger. Check the ball's equator. A random point on it has farther to go in just one spin than any point near your finger. That means the point on the equator is moving more quickly. The Earth is a planet that recycles all the time. The ground we're walking on is recycled. Our planet's rock cycle turns rocks of one type into another. That's a cycle that goes on and on. The depths of our planet are filled with magma. As magma is going out onto the surface, it hardens into rock. Tectonic processes like volcanic activity, earthquakes, mountain building, and all of the other processes that shape the surface of our planet bring that rock to the Earth's surface. When the rock is on the surface, erosion shapes it and shaves its bits off. Those small particles then get deposited. All the pressure coming from above compacts the particles into sedimentary rocks, like, for example, sandstone. Sedimentary rocks can also end up deeper and deeper under the Earth's surface. Since there's a lot of heat and pressure, they get cooked into metamorphic rocks. They can go back to the surface once again, or even end up being re-eroded. Sometimes the crust plates are pushing one under another, and this way, rocks can transform into magma once again. We've explored only 5% of the ocean so far. The ocean itself, as well as life below the seafloor, is still a mystery. The sediments that are underlying our oceans are home to different microorganisms that exist even at depths of 1.5 miles beneath the seafloor. There are microbes hidden deep inside volcanic rocks below the seafloor off of the parts of the Pacific, hidden under 870 feet of sediment. The biosphere under the seafloor is growing extremely slowly compared to life on the surface. Cell division happens every 10 to 1,000 years. Something's different about the Earth's axis. Climate changes and melting glaciers, mostly in the regions like the Himalayas and Alaska, made the axis shift. Our planet has two kinds of poles. Are the south and north magnetic poles. They affect things such as drift and navigation. The axis that the Earth is spinning around is another kind of pole. It shifted a little bit over time, but we don't know exactly why. Researchers realize there are moving masses of water, pushing the Earth's axis eastward. Take a basin of water as an example. If you're moving it back and forth, sloshing makes the water move its weight all around. A similar thing is happening on a planetary level. No matter how large an earthquake is, no human could ever feel an earthquake on the opposite side of the Earth, although some people claim they did. In 2013, there was one near the Kuril Islands with a magnitude of 8.5. It went around 400 miles deep. It was so strong, people in Australia reported they could feel the ground shaking. The strongest earthquake happened in Chile. in 1960 with a magnitude of 9.5. The rupture zone stretched from 311 miles to almost 620 miles along the country's coast. Earthquakes with a magnitude of 10 or higher can't happen. The magnitude depends on the length of the fault where it occurs. The longer the fault, the bigger the earthquake. A fault is a break in a part of the planet's crust. It has rocks on both sides, and they move past each other. We haven't found a fault long enough to generate earthquakes with a magnitude of 10 or more. If it happened, it would extend around most of our planet. An earthquake with a magnitude of 12 would require a fault larger than our planet. One side of our planet is getting colder than the other. The Earth has a system that keeps it warm from the inside, a red-hot liquid interior deep below the surface. It spins and, at the same time, generates a magnetic field and gravity. That way, the Earth's core holds the atmosphere closer to the planet's surface. The Earth also absorbs heat from the Sun, mostly on the surface. The heat doesn't spread equally on all parts of the Earth. One side of the planet, the Pacific Hemisphere, is losing heat more quickly than another, the African Hemisphere. This happens because land traps more heat than the surface under the ocean. The seafloor is way thinner than the landmass. Also, the temperature caused by the heat coming from inside the Earth is getting lower because of huge amounts of cold water above it. Clouds are not just like some fluffy distant pieces of cotton. They weigh more than 1 million pounds and help regulate our planet's temperature. If you take all the water droplets in clouds and bring them to the surface, you could cover the planet with a liquid layer as thin as a human hair. It doesn't seem like a lot, but this water is crucially important for climate. We'd have warmer temperatures if it weren't for the clouds.
Hey, I want to show you something. Let's take a little trip off of Earth and park our spacecraft somewhere near the moon. We're now almost 240,000 miles away from our home planet. That's almost 100 times the width of the United States. Now we've brought a special set of tools with us, a giant hammer and an enormous chisel. Place the chisel at the Earth's North Pole and strike its head with the hammer. The Earth cracks open like an eggshell and we see another planet. This is Theia, and it's hiding inside our planet like a yolk in an egg. If you want to find out how it got there, you'd need to travel back in time 4.5 billion years. This beautiful nebula is what will eventually become our solar system. Colored dust and various space debris are slowly coming closer toward the common center. Over time, this jigsaw puzzle of debris becomes denser and heavier. The temperature inside the giant is rising. Soon, it gets so high that it'll trigger a nuclear chain reaction. One more second, and bam! There's an explosion so powerful that the shockwaves travel far into deep space. When the dust clears a little, you can see that a bright light is still shining at the very center of the explosion. This newborn star is the Sun. It weighs as much as 333,000 Earths. If the Sun was a bucket, you'd need 1.3 million Earth-sized planets to fill it. But we're interested in that small object over there, 93 million miles away from the Sun. This pile of rocks and hot lava is Earth. Right now, the planet is busy forming its core while the oceans of lava are gradually cooling down. But some millions of years later, after the Sun's birth, you notice another small object. Here comes Theia. This small planet was formed at about the same time as Earth, and right now, it's following a crazy spiral trajectory at enormous speed. Scientists believe Theia was like a ball Jupiter and Venus played around with. Venus would pull Theia in one direction, and then Jupiter would pull it right back. But what makes up 99.8% of the mass of the solar system is the Sun. It's what makes Theia move into almost the same orbit as Earth. So they inevitably come closer and closer to each other until they become next-door neighbors. We see that Theia is roughly the size of Mars, as wide as the Atlantic Ocean from New York to Portugal. At this point, the collision can't be avoided. Theia is traveling towards Earth at nearly 9,000 miles per hour. That's 11 times faster than the speed of sound. If this smaller planet would crash into Earth at a particular angle, Earth would most likely be torn apart, as well as Theia itself. The collision would cause a huge blast visible on other planets, even on a bright day. Nothing would be left but some burning dust and debris. Even if Theia only slightly grazes the Earth, it'll still knock out a sizable chunk. But the collision with Theia happens at a perfect 45-degree angle. It strikes the Earth at tremendous speed. The explosion literally vaporizes huge amounts of rock, and the shockwave sends the remaining debris into Earth's orbit. A huge crater is formed at the impact site, which soon gets filled in with boiling lava. The remnants of Theia and the ejected fragments of Earth begin to orbit our planet. According to one theory, these fragments actually form two moons. At first, they travel together, but one day they get too close to each other and collide, forming one large space body. The other theory claims that all the loose shards get pulled in by the remnants of Theia, and that sometime after that, they form the moon, as we know it today. At this point in the past, though, it's just red-hot rock and lava. The collision at this angle slightly tilts our planet and accelerates its rotation. It's because of Theia, though we have different seasons and 24 hours in a day. Now, Earth also has these things called lithospheric plates. These are enormous solid land masses that make up the crust of our planet. After the collision with Theia, they start to break and crack. It causes carbon, a primary component of all known life on Earth, to start moving all over our planet, so Earth gains a kind of metabolism. After a few 100 million years, the first living creatures start to appear on our planet. Over the next nearly 4 billion years, simple single-cell organisms evolve into the kinds of complex life you see today. According to scientists, a collision like we had with Theia is a very rare event. The probability that somewhere out there there's a planet like ours that has survived the same catastrophe is even rarer still. This may be the reason why we have yet to find other traces of other civilizations out there in space. Meanwhile, the remains of Theia are still here on Earth. Of course, it doesn't look like an actual entire planet stuck inside our own. Most of the fragments have melted and blended into the Earth's crust. If you take the top layer off our planet, you'll see two huge lava blobs the size of large continents. They're right below Africa and the Pacific Ocean. Presumably, these are the remains of Theia. They didn't mix with the Earth's mantle because of different densities. It's like mixing water and oil in a glass. The oil will always float up over the water and create an even layer on top of it. But if you raise these lava patches up to the surface, they'd be 100 times higher than Mount Everest. Other remains of Theia might be on the moon. The Apollo space missions brought back many soil samples for analysis, which led scientists to conclude that the moon is very similar to the Earth in structure. Someday in the future, people could drill deep down and take samples of the moon's crust. Then they'd analyze the blobs from Earth, and if their structure matched, it would be undeniable proof that Theia did hit Earth 4.5 billion years ago and gave us the moon. But for the time being, Theia remains an unsolved mystery. Scientists are still not sure that the planet actually existed. The whole idea does perfectly fit the model of the moon's creation, but it's also possible that this incredible collision may have never happened. Now, let's travel 41 light years away from Earth to the planet 55 Cancri E. It's about twice the size of Earth and 8 times heavier. Let's take out our giant hammer again and use it to hit the chisel. The planet cracks, and you see it's a giant diamond. The temperature on this planet is tens of times higher than on Earth, and its soil is rich in carbon. The heat puts a lot of pressure on this carbon, and the structure changes. First, it turns into graphite, but then add just a bit more pressure, and the graphite turns to diamond. On Earth, diamonds form at depths 60 miles below sea level, where the pressure is 50,000 times greater than that on the surface. And the temperature there averages over 1,000 degrees, which is as hot as fire. Diamonds are often ejected closer to the surface in volcanic eruptions, but still, people mostly have to dig mines 1,500 feet deep to find these beautiful gems. Currently, the Golden Jubilee diamond is the biggest cut and faceted diamond on Earth. It weighs as much as a chocolate bar and is the size of a hamster. Its price is about $12 million. Now, imagine a diamond the size of an entire planet! Now, let's fly back to our solar system. Our destination now is Jupiter's moon, Europa. It's as wide as the distance between Seattle and Houston, and its mass is less than 1% of the mass of Earth. Its surface is enclosed in an icy crust that's about 19 miles thick. Europa is completely covered in water. It's freezing here, 3 times colder than that of the North Pole and Earth. The water turns to ice almost instantly. But the ocean beneath the surface is still liquid. Europa has a gravitational relationship with Jupiter, just like the moon with the Earth. This creates tidal forces that heat Europa's core, which then melts the ice around it. The result is a huge ocean, 2 or 3 times larger than that of Earth's oceans combined. Scientists believe that water is one of the essential ingredients for life. This means that life may exist on Europa. There could be thermal springs, just like at the bottom of our oceans, though the water there is probably much warmer. And even though the pressure and temperature in such places are likely to be extreme, simple bacteria could live there. Europa is almost the same age as Earth, so there has been enough time for living organisms to appear and evolve. Who knows, maybe some advanced civilization is already blooming under this crust of ice. They might be building big cities and dreaming of conquering space. But for now, all we can do is speculate, and maybe someday send a probe to Europa to find out if life is possible there.
There are many miles of undiscovered areas beneath the crust we can't even come close to. Scientists found what appears to be underground mountains buried inside the mantle. Our planet is divided into 3 layers: the crust, the mantle, and the core. The crust is where 8 billion people, trillions of trees, and millions of animals live and thrive. There are also different types of crust in the land and the ocean. The oceanic crust contains unique rocks and is denser than the land crust. We all see how the Earth is divided and color-coded to show the crust, mantle, and core in textbooks. But there are also special layers in between that not everyone talks about. The mantle is divided into the upper and lower part, which is the transition zone. Since the mantle acts as the geological recycling center, the plate tectonics don't only move side to side, but up and down. It's actually why all the volcanoes appeared. The magma spews out to the surface or even underwater, and then sinks back down and repeats. The transitions go down 250 miles and then 410 miles. And in this bottom layer, scientists keep discovering the hidden landscapes. The mountains in the mantle are more rugged and much larger than the ones on the crust. Scientists found a mountain range with peaks higher than Mount Everest. Some of them are as high as 600 miles. When the continents were still landlocked together, there may have been some hidden lands now underwater. Theories suggest that Iceland used to be part of a larger microcontinent, Icelandia, which connected present-day Iceland with Greenland and Scandinavia. The idea digs even deeper to a greater Icelandia, which includes Britain. But after the split, these bigger lands sunk with everything in it. There are also theories about New Zealand being part of Zealandia, a hidden microcontinent within the same region. So it could be that these mountains used to be part of old Earth that are underground over the billions of years of natural occurrences. But still, it isn't very likely. One theory is that these underground mountain ranges could be leftover slabs of rock that descended from the surface to the transition zone from the moving of the tectonic plates. As they sink, the large pieces break down into smaller ones, and as they compile over the millions of years, they form what appears to be underground mountains. Since the mantle is the geologic recycling zone, it's likely that the rocks down there used to be part of the surface. They weren't large pieces of land that got hidden, just like dogs hide bones in the garden, but it takes way more time to hide mountains. Some parts of the mantle appear to be smooth, while others aren't so much. The parts that have a cluster of rocks could contain hidden elements in the underground mountains. The smoother parts don't have much seismic or volcanic activity, while the rough parts do. The best way to study those underground landscapes is to wait for an earthquake or a volcano eruption to happen. Seismologists can observe the Earth's interior with special scanners, just like doctors use ultrasound to examine a patient. They can even see minor details and not huge chunks of rocks. A strong enough earthquake can send shockwaves to the Earth's interior, even through the core and back up to the surface. Depending on where they occur, seismologists can observe and study the intensity of the waves as they move back and forth. On smooth rocks, the waves can travel in a straight line, but once they reach a rough area, the waves tend to scatter. The temperature and composition of the materials can make the waves move faster or slower. But this info isn't exactly accurate and won't contribute a lot to the actual data of the underground mountains. So, by analyzing the scattered waves on ships and utilizing the Earth's magnetic field, scientists can figure out everything they need to know. But these studies are only good enough to figure out the interior in today's state, not how the Earth changed over the past 4.5 billion years. However, scientists are certain that mantle material still dates back to the beginning of Earth's original formation. The question, why not just dig a hole to the center of the Earth and see what's going on down there, might seem logical. The deepest hole humans have dug so far is the Kola Deep borehole in the Russian Arctic that goes more than 40,000 feet deep. The locals claim they can actually hear screaming coming from below. It took almost 20 years to drill as far as they went, but it's literally merely scratching the surface of what's underneath. They dug about 1/3 of the crust, which is only 0.2% to the center of the Earth. Getting there is beyond us, just like trying to reach the sun. No human can handle the amount of pressure down there. Going down the Mariana Trench, the Earth's deepest point, requires special gear to withstand all the immense pressure. It'll cost a fortune to build that tech to get us to the center of our planet. Evidence of diamonds buried deep in Brazil shows that everything we do on the crust's surface can affect things miles below, even towards the mantle. Scientists dug up 6 diamonds that could hold tiny mineral grains. As they're called in the mineral world, these inclusions have a chemistry composition where they originated deep in the Earth. Typical diamonds are formed at depths less than 125 miles in the upper mantle, where it's extremely hot. The high pressure and boiling temperature down crystallizes carbon and creates diamonds. But humans can't dig all the way down there. They mine them by detecting where a deep volcanic eruption happened that expelled these diamonds to the surface. These eruptions occurred millions of years ago, when dinosaurs used to rule the Earth. They shot out the diamonds that were in the mantle and are now embedded within the cooled down volcanic material. That's where people mine them. But these special diamonds found in Brazil originated from a much deeper point than usual, which can further help scientists study the depths of the Earth. They can extract these inclusions and analyze them in a lab to tell where exactly these minerals come from. In the lab, scientists study inclusions, each just 15 to 40 microns wide, less than a quarter width of a human hair. They found out that they contained many types of minerals found in volcanic rock on the surface. The carbon composition of the magma from the surface is much different than the ones deep in the Earth. What's crazy is that these diamonds with special inclusions can only be found 435 miles in the lower mantle. With only a few samples of them found, we don't know what else lies beneath us. It's possible that those mountain ranges underground, taller than Mount Everest, can have traces of diamonds all around, which would prompt excavators to dig them up and saturate the market with them. These diamonds are less flawed than the usual ones and might even come in many sizes. It's possible to see diamonds as large as a car or as small as a grain of rice. There might even be new diamonds with different chemical compositions than the ones we find near the surface. The largest diamond in the world is the Cullinan, which can fit in the palm of your hand. It weighs around 1.3 pounds and is 3,100 carats. It was found in 1905 in South Africa. For anything to exist on Earth, you need carbon. In a nutshell, the carbon cycle is when plants and algae release carbon dioxide into the atmosphere or dissolved in water through photosynthesis. It's converted into carbohydrates and stored as fat. Later on, carbon dioxide is released into the atmosphere through breathing, which the plants benefit from, and the cycle goes on. Scientists claim that there might even be a carbon cycle in Earth's interior. The oceanic crust has a lot of carbon sediment that could mix with the upper and lower mantle layer. But there still isn't enough evidence to support this. The deep diamonds might be the key to popping open that theory. Only time will tell.
Before we get into the reason why and how there are pyramids all around the world, let's talk about some of the examples. I'll start with the Pyramid of the Sun in Mexico. These folks really knew how to build a city. Their well-planned urban center spanned over 7 square miles and boasted several pyramids. But the Pyramid of the Sun is the most impressive. This giant pyramid was built way back in 100 CE and is one of the biggest structures of its kind in the whole Western Hemisphere. It's so big that it's 216 feet high above the ground. If you ever find yourself in this ancient city, you won't be able to miss the Pyramid of the Sun. It's right there on the east side of the Avenue of the Dead, the city's main north-south street. To build this incredible pyramid, around 1 million cubic yards of material were used, including a special kind of red volcanic rock called hued tizontle. Impressive, huh? We don't know too much about the people who built the Pyramid of the Sun or its purpose. But archaeologists believe there was once a temple on top of it. When explorers went below the pyramid in the 1970s, they found a bunch of cool tunnels and chambers. In 2011, they even found a secret stash of clay pots, obsidian pieces, animal bones, human figurines, and a mask. Who knows what other secrets the pyramid is hiding? If you decide to see this one, you must climb the pyramid using the 248 uneven steps on the west side. Watch your step. Sudan got some pyramids too. Nubian pyramids aren't as big as the ones in Egypt, but they still got around 200 of them. These ancient pyramids have been home to the tombs of the pharaohs of the Meroitic Kingdom for almost 1,000 years, who ruled Egypt from Nubia to the Mediterranean Sea. The pyramids at Meroe were constructed using granite and reddish sandstone. Oh, and did you know that Sudan has more ancient pyramids than Egypt? The Kushite pyramids depict the indigenous architecture and burial traditions of Nubia's Napata and Meroe kingdoms, which ancient Egypt influenced. Meroe, the burial site of over 40 queens and kings, is the most extensive Nubian pyramid site. The tomb walls depict mummified royals bedecked in jewelry, their wooden caskets containing bows, quivers of arrows, and other artifacts pointing to the Meroitic relationship and trade with Egyptian and Greek civilizations. So if you're looking for some ancient tombs to explore, you may consider skipping the crowds in Egypt and heading on down to Sudan. Let's fly to Iraq to see some more pyramids. Ziggurats have fancy receding layers and tiered temples. Instead of a smooth exterior, it has tiers like a cake. Perfect for all the important work and rituals that went on inside. You can find these towering structures scattered throughout Iraq and Iran, and they're a real testament to the power and skills of the people who built them. One of the biggest and most impressive ziggurats is the ziggurat at Ur. It's basically a giant rectangular pyramid that stands a whopping 70 to 100 feet tall, with 3 levels of terraces and a temple on top. Can you imagine how many baked bricks it took to build that thing? Try 720,000 for just the lower portion. This particular ziggurat was built for Sumerian king Ur-Nammu. Similar to other ones, this pyramid has been around for thousands of years, so it got a little rough around the edges. Thankfully, the Babylonian king Nebuchadnezzar II and some archaeologists came to the rescue in the 6th and 20th centuries respectively, and now you can find this near Talil Air Base. The ziggurat at Ur was built in 2100 BCE by King Ur-Nammu for the moon deity Nanna. It was the tallest building in the city, and you could see it from miles around. It was like the medieval cathedral spire of its day. People would come here to bring their agricultural surplus and get their food allotments and seek spiritual nourishment. Sadly, the Nanna temple at the top of the ziggurat didn't survive, but we do have some blue glazed bricks that may have been part of its decoration. The lower parts of the ziggurat are pretty amazing though. The architects even included holes in the temple's baked exterior to let the water evaporate from its core. Since we explored some of the pyramids on our planet, let's take a broader perspective. They can be found in many parts of the world. Egypt has over 100 pyramids, double that number in Sudan, and dozens of others are scattered in the Middle East and China. The Americas have the most pyramids in total, with more pyramids than the rest of the world combined. These pyramids are located in Mexico, Guatemala, Honduras, and El Salvador. Time to know more about the evolution of pyramids through history. The oldest pyramid is in Egypt. This pyramid was a step pyramid, which was created by placing one layer of stone on top of another. The pharaoh Sneferu is credited with creating the pyramid shape we recognize today. During his 45-year reign, he built 3 pyramids. His first 2 attempts failed, but he finally got it right with the Red Pyramid, which is considered the first true pyramid. It was Sneferu's son, Khufu, who built the Great Pyramid of Giza, which was the tallest human-made structure on Earth for almost 4,000 years. Latin American pyramids are similar to early Egyptian step pyramids, but they were built independently, with no knowledge of each other. The pyramids in Sudan were built around 700 BCE and are tall, but much narrower than those in Egypt. How in the world did all these civilizations build these things without even texting each other? After all, the Aztecs, Mayans, and ancient Egyptians were about as different as possible. But despite their cultural differences, they all seem to agree on one thing. Pyramids were pretty cool. Step pyramids are all around the world because they were the most feasible and stable way to build large and tall structures without access to lighter building materials like wood and metal. The triangular form with a square base is the best way to build a sturdy structure, and having a cube structure would require more material for less height. Now, when it comes to pyramid design, the Egyptian pyramids were like giant triangles with a square base, smooth sides, and a pointy top. On the other hand, the Aztecs and Mayans went for a tiered cake look, with steps leading up to a flat platform on top. So, while all these pyramids share the same basic shape, they have their own unique flair. Each group built its pyramids using different materials, techniques, and slope angles. So while they may have been inspired by each other's work occasionally, they were just doing their own thing. Egyptian pyramids had smooth, angled sides that were designed to help the pharaoh's soul ascend to heaven. The Pyramid of the Sun was built over a series of caves that served as a passageway for the deities. The Maya built the temple of Kukulkan in Chichen Itza to honor the deity Kukulkan, usually represented by a serpent. Nicknamed El Castillo, it has 91 steps on each side, plus a platform. That's 365 steps, one for each day of the Mayan calendar. Tell me, Brightsiders, how were pyramids built? To begin with, humans made them, not a foreign race from space that landed on Earth. You see, one thing that all pyramids have in common is that they were built without advanced tools or even the wheel. It took a lot of people to build them, including skilled laborers and architects. For example, it's estimated that 20,000 people built the Great Pyramid of Giza, and it's believed that most of them were skilled laborers. Building pyramids was a massive undertaking that required years of planning and effort. The Great Pyramid at Cholula, Mexico, took 600 years to complete.